Two important things. Each element means that every element in X is related to some element in Y. We say that the function covers X, but some elements of Y may not be related at all, which is fine. And then exactly 1 means that the function is single valued. It will not give back 2 or more results for the same input. So if I have f of 2, that's what they're saying here, it has to be 7. It can't be 7 or 9. Or the same function can't have the same input with different outputs, right? This is not a function if that happens. Now, it's okay to have the repeated output value, right? This can still be a function because the input 3 has an output, 7. The input 4 has exactly one output, 7. This is like the vending machine that has 2 buttons that give the same drink, but it always gives those drinks, right? That's the thing, it's consistency. The input gives the same output. Okay, so we're going to be taking relations and we're going to represent them in a table, in a graph, and as a mapping. And then we're going to determine if it is a function or not. So you can see here, this is a relation. This is just a set of ordered pairs. So if the ordered pair 2, 3, 4, 7, and 6, 8. Can we write that information in a table? I hope so. So the first ordered pair is 2, 3. The next one is 4, 7. And the last one is 6, 8. Oh my gosh.
I was working on it last night. I left it in my...
You did? You just working hard on it?
I actually swear I was just laying in my bed.
Okay.
I was going to put it in my backpack because I saw it when I was going to sleep and I was too lazy. I swear on everything. You can follow me home and go look at my room if you want.
If I plot it here, this is 2, 3. It's okay. I've made you keep up for that paper for like a whole day.
Yeah, that was one.
No, not a day. That's crazy.
I'll just do it when I get home.
Okay. There is the ordered pairs. And I know that's probably going to be hard to graph on those little big graphs, right? It's okay, though. And then, have you guys ever done a mapping before like this? Okay, so here are my rules for the mapping, okay? We want to put the x's in order from smallest to largest, which in this case they already are, right? 2, 4, and 6. We also want to put the y's in order from smallest to largest. 3, 7, 8. Again, this time they already were. That's not always the case, though. And we never want to have repeats, right? So if we have an output of 3 that happens twice, you just write 3 one time over here, okay, for the mapping. And then we just draw lines telling if I had an input of 2, the output should have been 3. If I had an input of 4, the output should be 7. 6 should give an output of 8. Again, this mapping's kind of boring, right? Because they all map straight across, but they don't have to. So the list of x's should be in order, least to greatest. List of y's in order, least to greatest. No repeats, and then you draw lines to connect them. So after looking at this relation, is this relation a function? It is a function because the 3 inputs, 2, 4, and 6, don't have repeated outputs. Each input had only one output.